So is my screen available to everyone? Please confirm.
Yes, sir.
Yes, sir.
Okay, so let's begin. Okay, so today we'll be talking about functions. We have already discussed functions, so we'll be going into a bit more detail. So let's start one by one. So the first thing which I would like to tell you is something known as a lambda. So I'll explain everything with the help of an example. So let's say I have a file temperature.py in which I want to convert a temperature entered in Fahrenheit into centigrade, right? So the question itself is quite straightforward. So I'll just say that, okay, f is equal to, we'll get the input from the user. We'll just say f is equal to, we'll convert it into integer, we'll get the input, and then I'll say enter temperature in Fahrenheit, right? So the temperature is entered. And now how do you convert? There's a formula. The formula is C is equal to 5 divided by 9 into f minus 32, isn't it? And then what we do, we display it, simple. Print C. And if I run it, and let's say I give a value for which the answer is known. Let minus 40 is the easiest, I believe. So if I enter minus 40, what's the output which I'm expecting? Minus 40, obviously, right? So it's working. Now if I want to convert this into a function, how do we do it? We'll define a function. So I'll go to top, I say def, and what to call the function, let's say f2c. I'm calling it f2c because we are doing a conversion. We are passing the value of f, and then we'll just say return, followed by what we were doing earlier. So I'll just say this over here. So it will calculate and it will return, and whatever it is returning, we want it over here. So I'll say f2c, and then I'll pass the value. Any doubts till this point? We are entering a value, we are calling our function, we are passing the argument f. This argument f comes over here, we perform this calculation, and we return the answer. So obviously the answer will still be the same. So till this point there is no difference. Now these things are fairly common in programming, that you have one-line functions, and there is something in Python known as a lambda, using which you can shorten this up. In other languages there are other uses of lambdas also, but here it is just a shorthand notation to a one-line function. So see how it goes. So now what we'll do is, I'll just comment this out, and then I'll create a lambda. In order to create a lambda, you say lambda, lambda, you say lambda. That is followed by the variable or the argument. So that argument is f. Then we give a colon, and then we'll give the expression. Expression means this part. So I'll copy this from here, I'll paste it over here, and then I'll store it in a variable. So I'll say f2c is equal to lambda, and now if I run it, minus 40, I get 40. Got the point? So this is basically another way of defining a function, a shorthand notation, but please understand it has to be of one line. And there is no need for return. Why did I have this return over here? Sorry. So it will work obviously with oh no, a return is required. Yes, sorry. Working. Another thing which I would like to show you over here is that if at the end I go and say print type of that variable f2c, and I run the program again so that we can see the type, it will show you as a function. So that's actually a function. Hold on, something bad happened. Where is the lambda thing which I wrote? This got replaced somehow in the, wait, we have to do it again. So what we'll do, we'll just say that f2c is equal to lambda colon, no, lambda f colon this. Okay, that is being done by Visual Studio Code. It is understanding that what I'm trying to do and it is replacing. Okay? Which means that if you run it from some other program directly, it will still work the same. So just to show you that it works otherwise also, I'm not very happy with Visual Studio doing this and spoiling the class. So anyway, it's running. So what I'll do is, I'll just say Control Z. Hopefully it will give me back. I won't save it. I'll just copy it from here, and we'll run it without VS Code once, right? So nano temp.py, press enter, copy paste the whole stuff, save it, go out, and I'll say python 3 temp.py. This is the old way of running a program. So I'm telling the computer that, okay, run this file with the Python interpreter. I press enter, it asks me for the temperature -40, and I get the same answer and the same thing. So if I display it on the screen again, the whole program, right? So this is how lambdas work. These are just a shortcut way, and this VS Code is trying to help us that, okay, you want a shortcut notation, you write your own notation, I'll convert it, but that's a different story. This is how the thing actually works. Any doubts, please let me know. Right? Okay, so we'll go back to VS Code now, and we'll move on to the next point. So I don't want to save it, but then as soon as I save it, again this is done. Anyway, there is a way to turn it off. I don't want to waste time to turn this off, so this is okay. Is this clear to everyone? No doubts?
Yes, sir.
Okay. Now the next point is going to be a very interesting one. So have you ever heard about Fibonacci series? Must have. So Fibonacci series, I'll explain everything with the help of an actual example. I don't want very toyish example. These are still toyish examples, but okay. So a Fibonacci series is basically a series in which the first two terms are fixed. First is 0, second is 1, and the remaining terms are obtained by adding the previous two terms. So first term is 0, second term is 1, the third term will be 0 plus 1, 1. Then the next term will be 1 plus 1, 2, then the next term will be 2 plus 1, 3, then the next term will be 2 plus 3, 5, 5 plus 3, 8, and I don't want to waste the entire class on this, right? So this is how it will go on. Any doubts in this? No? Okay. So let's say I want to create a function which will generate n terms of the Fibonacci series, right? So I'll say def Fibonacci, and I'll want to give the number of terms, so I'm calling it terms. And then I'll just write pass over here. Pass over here means that it's not doing anything, but since syntactically I'm supposed to give a body, so I'm giving a blank body. And then what we'll do is, we'll ask the computer to generate the Fibonacci term. So if I say Fibonacci 5, I want how many terms? 5. So let's try to do this. 5 terms. So we'll take 3 variables. The first variable is for the first term, which is 0. The second variable is for the second term, which is 1. And then what we'll do, we need to repeat it a certain number of times. How many times? This many times, yes. In this particular case, 5 times. So what I'll do, I'll take a loop. I'll say for I in range, and then I'll say terms. So this will run that many times. Any doubts in this? So like for example, if I just say over here print asterisk, it will display how many asterisks? obviously as many as the atoms, because the loop is starting from 0. In the range I am giving only one number over here. So the starting point is 0, then 0, 1, 2, 3, 4, so you are getting 5 asterisks, right? Now what I'll do is, I don't want to display the asterisks obviously, so I'll display the value of a. And once that is done, I need to do a bit of shifting, just to explain. So, where's the window key? Here's the window key. So, there's a variable a, which is 0. There's a variable b, which is 1. And now I have displayed the first value, which is 0. So, right now the output is 0. But when the next time it comes, I want this to be a, and then I want this to be recalculated. That means 0 plus 1, 1 over here. And then this should become b, isn't it? And then next time we'll get a new c, 1 plus 1, 2. That's how it goes. So going back to the coding screen, so what I'll do is, I'll do the shifting. And before shifting, I have to add. So first I'll say that, okay, c is equal to a plus b. So 0 plus 1 is 1. And then I'll shift it. So I'll say that, okay, a is equal to b. And then I'll say that, okay, b is equal to c. The shifting is done. So I'll run the program again. And you can see 0, 1, 1, 2, 3. Is it making sense to everyone? Any doubts before we make it more complex or add more features, to be precise? Clear to everyone? Any doubts, please let me know. Okay, so everyone is saying it's clear, so we'll proceed. So this is how it's working. Now, this is not a very good way of doing things. Why? Because whenever I'll run this, computer will generate the term and it will display on the screen. The problem over here is that displaying something on the screen is not a very good idea always. For toyish programs, it's okay. But the thing is that it will always be printed and someone cannot do anything with this. So let's say I want to return it. Now the point is, if I place a return directly, let's say for example I say return a. Now what will happen? Will it run that many times? No. We'll call the function, it will go over here, but as soon as it reaches over here, it will return the value and it will finish. So you'll only get back the first value. So if I just say print this. So obviously only the first value was returned and the function finished. Now this is not what we are trying to do. So any ideas? Any idea what we can do? Yes, the simplest thing is that we can use a list. I can create a blank list in the beginning. I can say that, okay, fib is equal to blank, and wherever I am getting the term, instead of printing the term, I'll say that, okay, fib dot append, and then I'll append it. That means I'll say a. And obviously now the list has to be returned, so I'll say return fib. So what is happening in this case is that we have created a list, and instead of printing the terms which we were doing earlier, now what we are doing, we are adding it to the end of list, and when everything is done, we are returning the list. So now if I run the program, computer will give back the list. Now if you notice, everything is in box brackets, so that means that it's a list. If you want to verify, who will tell me how to verify? We'll say type, and we'll say FIB, so it will display that, okay. Oh, sorry. We have to give the whole thing. So basically we are calling it twice, but that's not a problem right now. What I'm trying to demonstrate is that it is returning back a list. A better way obviously would be to first store it somewhere and then just do the needful. So I display the list and I display the type as well. So this is the better way of doing the same. Any doubts till this point? Okay, now this happens in all the languages. Like in other languages, you just create an array and return the array. This is okay. Now there is a problem with this approach, and that problem, and one more thing, this is iterable also. Like for example, if I want, I can comment this line over here, and since it's returning a list, and let's say I do want to print the list one by one, so what I can do is, I can say that, okay, for term in list, and then I simply print the term. I say print and I say term. So this will print one by one. So if you want to print, you can print. If you want to find the sum, it's not very difficult to do. You will just say sum is equal to 0, and where you are printing, you can simply say that, okay, sum plus is equal to term, and once it's over, you can display the sum also. Sum is, and we display the sum. Right? And is the sum correct? Yes, it's correct. So if you want to ask something, you may ask now before I take it one step further.
I was expecting like there's this functionality in Ruby that you can sort of save the function stack frame so that when the function is called again, it's sort of like it starts from
Exactly. So before I'll just like to elaborate on what he's saying. Now this is working and everything seems to be okay, but there is one more issue still, and that is if the value is long, it will take time. It will take a lot of time because first it will calculate the whole list and then it will return back the list. Like for example, if I run this, I don't know whether you felt it or not, but it was slightly longer, right? Okay. Now there is another feature over here in which we can do it in a bit different way. So like what I'll show you with the help of an example. I'll leave this example over here and I'll create another example. I'll just call it demo.py. Now notice what I'm doing. I'm defining a function f. So there's a function f, and within a function I'm saying return, and I'm just returning a value, let's say 1. I go to main and I say print f. What do we expect? 1. Okay. Now if I give 2 returns over here, and let's say I call it 2. Now what do we expect? 1. Obviously it will, as soon as it finds the first one, it will return. Now there is something in a Python known as yield. So, and before that, if I do it twice, like for example, if I repeat this line twice over here and I run it, still it will give me 1 1 twice because I'm calling the same function, and every time you call a function, this starts from the beginning. Now let's say I replace this with yield, Y-I-E-L-D, and I'll make this into Y-I-E-L-D. Now notice what happens. Now when I'll run it, it will call this function, it will go over here, return 1, and it will remember that it executed till this line, and when you call this next line, it will continue from where it stopped. So next time it will return 2. Notice. Oh, sorry, we are not, we are returning the whole object. So what we want to do is, we want to print this.
since it's an object, dot value might start out as something like that, a function or something.
No, we are actually, hold on. We yielded 1, we came back, and it is saying, okay, hold on. So it's returning a generator thing. So what I'll do is, I'll just say for I in, we want to iterate whatever is being returned. So for I in f, and then I'll say print I. Now you'll see what happens. So if I run it, 1, 2, it first returned 1, and then it returned 2, and then it finished. Making sense? So it is continuing from where it stopped. So let's say I copy this again, place it over here. So now what? How many times it will iterate? 3 times. So if I run it again, I'll get 1, 2, and 3. So basically what is happening is that it's similar to return in the sense that the value is actually substituted where it was called at, and it is different in the sense that it remembers the state and it continues from that state in the next function call. So if I go into this Fibonacci again, I can modify this using generators. Like for example, I can, no need for this return, no need for this list, and I'll simply say yield A. right? So if I run the program, obviously the answer will be same. Let us have a smaller value to see what is happening, because these big values it would. Okay. So first 0 was returned, then 1, then 1, then 2, then 3. And the good point over here is that you are not occupying a lot of memory. Like when we were using the list version and we passed 500, computer first created a list of 500 elements, and then that array, the entire list was returned. So it took that much of memory, 500 into size of one location. But here what is happening? It is only taking this many variables and it is returning one at a time. So it won't, the memory requirements are also not very high. Is it making sense to everyone? Sure.
Yes, sir.
Call the function again just after when you're doing just something.
You can call it again, it will still begin from where it was actually.
Exactly. So let's say you wanted to have the first 5 terms, and then you said, okay, I want the first 3 terms. That sort of creates a bit.
Yes, then you are supposed to take another variable. Like every time you are doing it with a new thing, you just, yeah, exactly. That's the problem which it will have. We can circumvent this problem by putting this inside a class and then having a separate function for initializing that, but that will come later. Right now, my focus is on explaining what is yield and how it functions.
Nice, yeah. And I think this exact same keyword is in movie as well. Just remembered it.
Okay, this is one thing. Now let us say we want to apply the same logic to, just for the practice sake, to some other program as well. Let's say prime. Okay, we never did a prime function in this. So let's say I want to find whether a number is a prime or not. So first we'll do it the regular way or the bad way, whatever you want to call it. So let's say I want to check whether a number is prime or not. By definition, a prime number is a number which has only 2 factors. So you just count the number of factors and you get whether or not it's a prime. So let's say I want to count the number of factors, so I say that okay, initially count is equal to 0. I take a loop, I say that okay, for I in range, and then I'll give a number. So let's say we start from 1 and we go till n plus 1, and then we'll say that if n modulus I is equal to 0, that means it's a factor. And if it's a factor, we'll say that okay, count plus is equal to 1. Even that can be done. I'm just coming to it. We'll optimize it. There are many students over here who have probably not done this before, so we'll give them the proper approach. So, and then we have counted all the factors, and then later on we can check. We'll say that okay, return if count equals 2. Now please note, I am checking over here. If count is equal to 2, it will either evaluate to false or it will evaluate to true. If it evaluates to false, we will be returning a false. And if it evaluates to true, we will be returning a true. So let's try out with some value. So I'll say print. We'll check whether 1 is prime or not. And we'll check for some other numbers as well. Or let's say we run a loop simply for x in range, and I say okay, display all the prime numbers between 1 and 100, right? So we'll say that okay, if is prime x, display the value, as simple as that. So let's run the program and see whether it's working or not. Oops, sorry. There has to be a tab over here. So are these prime? Please confirm. Yes, they are. So the program is working. Now many a times what students do, you get an answer, you are happy. But please understand, this is a very heavy program right now. If I give, let's say if I make the range into 1 million, and when it is searching, when it is checking for million, it will actually run million times, isn't it? So what we can do over here is we can try to optimize. Now here, as Parth said a couple of minutes ago, if you are finding a factor, what does it mean? First factor is okay, second factor is okay, but if you get the third factor, what does it mean? That it cannot be a prime, isn't it? Now if you notice, in prime numbers what happens is that 1 is divisible by, sorry, every number is divisible by 1 and every number is divisible by itself, isn't it? So if we start the loop from 2 and we finish the loop at 1 less than the position, then obviously if you are finding any factor, it is going to be the third factor, isn't it? We are not starting from 1, we are not going till the number. Because when you say range 2 comma n, the loop will start from 2, 3, 4 and it will stop 1 before. So if the value of n is 10, it will stop at 9. So obviously if the number is getting divided by any number in between, it's not a prime. Make sense? So what we can do over here is we can say return false if it is divisible, and we can say else return true. Now please note I'm using a Python feature where this else belongs to this for. So if the loop doesn't complete, we'll go over this. So if we run it, are we getting the correct answer still? No, we are not getting the correct answer. Now we are getting a 1 also. How to get rid of 1? Anyone? Other than 1, rest is okay. Yeah, because 1 is a special case, so you may check for it. That okay, you can say that okay, if n is equal to 1, return false, and then it will work. Now this is not a very good solution. This is mainly a workaround. Okay, now let's try to improve it further. Any ideas how to proceed? If you want to improve it further. No one? Okay. So what we'll do is we'll try to improve it, and in order to improve it, what I'll do is we'll go to the beginning and we'll write a proper one. So please note that 2 is the first prime number, isn't it? So any number less than 2 is not prime. So we'll say that if n is less than 2, return false. Make sense? And 2 is also the only even prime number. So 2 is a special case. So if n is equal to true, 2, we'll say return true. Now if you are reaching this line where the cursor currently is, that is line number 6, what does it indicate? So it indicates that the number is more than 2. That's why you are at that line. Now we'll say that okay, if the number is even, please understand even numbers other than 2 are not prime. So we'll say return false. And now if you are reaching till this point, we are sure that the number is odd. Any doubts in this? No. Okay. So if the number is odd, I'll show you one more thing. Let's talk about any number. Let's say we are talking about 100 is the easiest example to see. Whenever you get a factor, you get factors in pairs. You don't get a factor in isolation. So if I say that 100 is divisible by 1, 1 into something is 100. Which means that the factors in this case of 1 is that okay, 1 into 100 is 100. The next factor is 2. 2 into what is 100? 50. So 2 into 50 is 100. Similarly, 4 into 25 is 100. Let's do it quickly. 5 into 20 is 100. Then we get the factor 10. And 10 into 10 is 100. Then we go further down. Then 20 into 5 is 100. 25 into 4 is 100. Then 50 into 2 is 100. Then 100 into 1 is 100. Now you must have noticed it. There is a repetition, like beyond this point, after this, there is repetition. I've already done 5 into 20, why I am doing 20 into 5? I've already done 4 into 25, why I am doing 25 into 4? And this repetition is actually starting at the square root. So this is the property which I wanted to show you, that beyond the square root, the repetition starts. So what we can do over here is, we'll go back, and if I am reaching this point, let's do it again. If I am reaching this point, what I'll do is, I'll calculate the limit. I'll say, okay, limit is equal to int, and I want to find the square root. In Python, if you want to find the square root, you have to use the math module. So we'll go up, we'll say import math, and we go down over here, and I'll say that, okay, find the square root, math.sqrt n. So we now have the square root, and now we'll take a loop. So we'll say that for divisor in range, and what will be the range? Please note, we have checked till 2. So we'll start from 3 and we'll go till our limit, which is the square root. And now what we'll do is, we'll check if the number is divisible by the divisor. What does it indicate? Come on, anyone? We are starting from 3 and we are going to the square root. So if you are finding any divisor, that is the third divisor, because every number gets divided by 1, and every number gets divided by the number itself. And since we are starting from 3, we are not going till the number you find any divisor. That means that it's not prime. So we'll say return false. Otherwise, we exactly, no, I'm coming to it. We'll do it in phases. If this loop completes, then we'll say return true. And now we come to the optimization which Parth is suggesting, that there is no need to go from 3 to 4. Why? Because even numbers other than 2 are not prime. If you are in this block, that means that it's not even, and obviously there is no point in dividing an even number. So we'll just go from in steps of 2. So after 3, we'll check by 5. After 5, we'll check by 7. After 7, we'll check by 9. So let's say if I'm trying to say whether 101 is a prime or not. In our first logic, using our first logic, the loop was running 100 times. But now it will run for 3, 5, 7, 9, and then the loop will finish. So after these tests, plus a loop of 4 times, we know whether or not. Of course, some effort is being taken in finding the square root also, but still it is much less. For larger values of n, this will be much more faster. So if I run it again, obviously the output is not going to change. We still get the same output. But this is a better solution because computer has to do less work when you are doing this. Any doubts in this? No? Okay. Yes.
So range should be till limit plus 1, na?
Right, yes. Because it will stop 1 less. So in some cases this might not work. So we'll say range is equal to limit plus 1. And that's why you're getting this, see, 15. 15 is not prime. Let's run it again. So 2, 3, 5, 7, 11, 13, 19. Yeah, now the other numbers are gone. Any doubts? Now let us say I want to involve generator in this. I want to generate a series, but I believe that's unnecessary. This is doing the job well, isn't it? Or should we use it? Okay, let's say we do it just for the sake of doing it. Okay, so I want a thing called prime. I'll give the number of terms and I expect to get that many terms. Make sense? So now our main logic will be, I don't want to do this range thing. I want to do prime 10. Straight away give me 10 prime numbers or 15 prime numbers or whatever. Make sense? And obviously this if also will vanish now. So this is what I'm trying to do. Any idea how to proceed? Who would like to guide?
Wait, what? Can you just use this is prime basically as I was talking about?
So here what we'll do is we want that many prime numbers, and I want to use the all the features which we have done till now. Yes, anyone would like to give some inputs before I do it on my own? I'll prefer that one of you give me some inputs. Okay, I'll do it for you. So which is the first term? 2? 2. So let's say I directly say yield term. 2 is the only even prime number, so it is yielded. Any doubts in this? No, but hold on, we want to return that many terms for what the user have given. So let's not do this. We'll say, we'll just run a loop for I in range. And what's the range? 0 comma term. So this loop will run that many times. Clear? Now what to do? We need to get the first number and we'll return it if it's a, so we'll just say we start with the guess. I'll say that okay, guess whether 1 is prime or not. Yes. Any idea how to proceed now? We want to stop at the next prime, so I'll say while not is prime and I say guess. While not is prime guess. What we should do? We'll just increase the guess. Guess plus is equal to 1. So first time guess is 1. The loop is going to run 10 times. While not is prime guess. Is 1 is prime? Is 1 prime? No. It will become 2. Is 2 prime? Yes. So the loop will finish. And when we'll get out of the loop, we'll just say yield. Sorry, the spelling. Yield guess. And now if I run the program, notice what happens. It gets stuck at 2. What's the solution?
Wait for
It's not going beyond 2. Every time it is checking 2 only. So once 2 is printed, we have to check out the next number, isn't it? So we'll just say guess plus is equal to 1 again. So if I run it again, now is it working? Anyone would like to improve this logic? Can we improve this a bit? Or this is okay? Can we make this guess plus 1 is equal to 2? Anyone? Will it work?
wait, our initial guess is 1, right? If you make
No, for 2 it will not work.
yeah,
Okay, why it will not work?
because the 1 will jump to
Sir,
0.
because yes, sir.
So if I make it 2, just see what happens. If I make it 2, and I'll give a smaller number so that we can easily check what is happening. 5.
Wait, I think it will work.
So if I run it,
I that is
it will work actually. 2, 5, 7, 11, 13. And this is actually a better way. See, you're not probably getting it. What is happening is that first time we are checking whether 1 is prime or not. 1 is not prime, so we make it 2. Is 2 prime? Yes. And once 2 is prime and 2 is returned, we make it 4. So what is happening? Is it working? No, it's not working. The 3 is missing. So your initial apprehensions were correct. We cannot make that kind of an optimization over here. And like if you place an if and then you do it, then it actually defeats the purpose. It's still possible to make it more efficient, but we'll stop it over here because then it will become more of a maths thing than a computer science thing. And there are some students over here who might not be knowing that much of maths, so we'll stop over here.
Excuse me, sir.
Yes, Karthik?
Sir, in which aspect is this program is this function more efficient than the previous one?
Previously we were not doing this. I'm just, hold on. Which one you're comparing with this, which one?
I am comparing prime with this prime.
From readability perspective, you're simply saying for x in prime 5 and you want 5 terms. It's very readable. That's what I'm saying. The complexity is hidden behind the prime function. Okay, so we'll. Yes,
What
Parth.
is a rooted function? So that's best. Yeah.
I couldn't hear
It's
you
a bit
properly.
confusing.
It is a bit confusing, but the thing is that now once it's it's working, it can be used anywhere. That's the good point.
Oh, all right. Yeah.
Okay. In tomorrow's class, we'll dissect this a bit. We'll try to make our own square root function using a very simple approach. And I'll suggest that you give it a try. The assignment for, just let me complete. The assignment for today is you try to make your own sqrt function, not the math.sqrt. So you, without using math.sqrt or any math class function, you have to write a program to find the square root of any number. Okay, and I just want a working solution, something not very bad, and I'm not looking for something very good. Okay. Yes, someone was saying something before I interrupted.
Sir, how can we print numbers in reverse order using for loop?
You mean to say the list is passed or just a
Just
sequence?
numbers.
Sequence. Okay, that's quite simple.
Yes, sir.
So let's say reverse dot pi, and so you are giving a number. Let's say you are giving so if you are giving 15, you want 15 to 1. Is that what you are saying?
Yes, sir.
Okay. So either we can use while, but I'm not using while. You want to while or for?
Sir, for loop.
Okay. So we'll just say for I in range, we'll say 15 because we want to start from 15. We'll say 0 and then we'll say minus 1. We want the step to be minus 1. We'll go over here. We'll say print I. Oops, sorry. Can it be done with range? So we can't do it with range actually, right? We'll have to use the traditional approach. There are other approaches also, but can anyone think of a better way with the range only?
Okay. Could you repeat what exactly
He's trying to take a number and he's trying to print from that number to 1 using for and preferably with range. Abhijit, am I understanding your question properly?
Yes, sir.
Okay, so you basically want to print all the numbers one after the other. So, and you want to use range. Okay. So why did we use -1 in the earlier thing?
Just to go back, minus one step, but it's not going to work. We can't do it with range. That's why I have a feeling. Just think about it. Wait.
See, a range is space. You can give a constant space, not a variable space to range. So that's the bad part of it.
So should we declare that it cannot be done?
What's the exact problem? Let's start from scratch, perhaps. Yeah. Wait, let me try. Let me create a code.
He's trying to print with using range. I mean, for normal while loop you can easily do.
Okay.
We can use we can use tricks like not directly with range, but we can do things like. But then you want to use for also, right?
Yes, sir. Actually, I was doing in that pattern program, and in pattern tricks, I was not understanding.
Okay, then you better use while if you are doing that kind of a thing. Otherwise, like we can use functions to wait. What's happening? Can you hear me?
Yeah. Proceed.
Okay, okay. The net went away actually for a while. Yes. So for that, I'll suggest that you better use the while thing.
Yes, sir.
Okay. So every
I think I didn't exactly catch the exact error. Why can't we use a for loop? What range function basically?
see. What do you want me to write? Come on, tell me. Okay, we'll simply do it like simply do it like this, because this also gives a generator internally. So if I say 1 comma 5, what happens?
We get a list from 1 to 5, 1 to 4
No,
actually.
I'll have to use the,
The for thing.
yeah. So if I say 1 comma 5, it gives 1 to 5, right?
1 to 4. Yeah.
1 to 4, yeah, exactly. So let's get a bigger number over here.
15. Okay.
Yeah. Now if I say minus 1, what will happen? Obviously it's not going to run, because it will go in the other direction and the condition won't be satisfied,
Uh-huh.
right? He wants
Yep.
the 15 to 1 thing.
Alright, you just replace that and it
Replace that by what? Like this?
exactly this should work.
Abhijit, does this solve your problem?
Yes, sir.
Okay, then
So
use this.
and let's say you're given two variables A and B, you don't know which one's bigger, so just use a single if to denote okay which one's bigger, and you don't have to worry about that anymore. So you can give the appropriate value.
This I don't understand what you're saying. Last point. Parth, what do you mean by your last statement?
Appropriate in the sense like if you give 0 to 15 and -1,
Hmm.
that's not gonna work in the sense
That will immediately finish. That will immediately finish. It won't generate anything.
uh-huh, yeah. And we wanted to generate from a bigger value to a lower value because we are having a negative increment or a
Yes.
decrement.
Right. Okay. So we'll meet tomorrow and we'll proceed.
Great, yeah.
Okay.
And
Thank.
it appears Shivesh is a bit, I don't know, yeah, for the web design class today.
I think we should cancel that other web design class today.
Today? Okay.
Yeah, because I have to repair my system. The other thing which is not working after the update anymore.
Okay.
Okay. Thank you.
Thank you.
Thank you, sir.
Thank you, sir.
Which update is it exactly? I'm going to be doing something similar.
I just updated the regular Ubuntu update. Nothing special, and it probably messed up with the drivers and all.
Okay. Thank you.
Okay.